Hello, everyone, and welcome to PyData Global 2025. We are so excited to have you join us. Feel free to use the chat to connect with fellow attendees and share your thoughts during the session. If you have any questions, please post them in the Q&A tab and we'll address them at the end of the session. Now, it's my absolute pleasure to introduce Tobia De Koninck, who will be presenting a talk entitled Accelerate Deployment of Your Python Data Science Apps Using ShinyProxy. Please give it up for Tobia.
Yes, thank you for the introduction. Hello everyone. We can get started. So, small introduction. I work for a company called Open Analytics, which is based in Antwerp in Belgium, and we do all kinds of data consulting, starting from the methodology side until more the software engineering and infrastructure side with things like data science platforms. So for today, I will tell a little story about someone trying to deploy a data science app, some issues the user experience, really some typical issues when deploying a data science app. And then I will tell a little bit about how ShinyProxy can help with those issues, and can help with deploying data science apps. So let's have a look at the story. The story is about Bob, who works at a big company. He's a data scientist, and he has just finished a major research project. He has analyzed all the data, and now his next task is basically to turn the results into an interactive dashboard. He loves building modules and apps and so on, but getting them into production, that's a whole new challenge for Bob. So when Bob starts working on his application, he does some research and he wants to build the application using Streamlit. After a week of hard work, he's done and the application is finished. He can show it on his laptop, and now he wants to present it to his boss. So what he does, he shares the links to the application with his boss, but soon the boss is frustrated because the app is not working. The boss is just getting an error page that the application is, or the website is not found or not able to display. Turns out that the application is only running on Bob's laptop, and this means that no one else can access it. Only on Bob's laptop they can access the app, but not any other colleague or team can access it. To fix it, they need a server, and the Bob asks the IT department to set up a server, which is approved, and soon Bob gets access to the server. So Bob has access to the server, he copies his code to the server, and he wants to start the application. Since it's a Streamlit application, he tries to run the Streamlit command, but he soon figures out that command is not found. And then he tries to just run a Python, but also Python is not installed. He does some Googling and he finds out he might need to install Python, but for this he needs administration permissions on the server, but he doesn't have the permissions. So he's a little bit stuck and he's unable to run the application. So he again contacts the IT department, and after some discussions, they are able to install Python and all the dependencies he needs, like the Streamlit application. So Bob is happy and is now finally able to run the application. He runs the Streamlit app, it works, and he can access his application. So he opens his web browser, goes to the IP address of the server, but it still doesn't work. He's still unable to access the application, still gets an error. So he's again a bit frustrated. He contacts IT department again. They have some discussions, and then the IT department says, okay, you can only run your application on port 443, and also you need to use TLS certificates. You cannot use any other port. You don't have the freedom to do that. So Bob has some work to do, but Bob is a data scientist. He doesn't really know what all those things mean. Doesn't know how to proceed. So he starts searching on the internet again, and he finds some documentation of Streamlit, and this documentation mentions he needs a reverse proxy to set up TLS. But again, Bob doesn't really know what it is. He gets even more frustrated. Yeah, he's again stuck. So he contacts the IT department again, and after some discussion again, they are able to help out, and they will configure the reverse proxy on the server. So he's lucky the app is finally working. He can present it to his boss. The boss is happy. Yeah, and they continue with their work. And because the app has been such a big success, Bob wants to start working on a new app for a new project. But whereas the previous app only used public data, or at least non-confidential data, there was no authentication required. But the new app he has developed is using or is handling confidential data, so it must be protected by authentication. Again, he starts searching the documentation. He finds a section about authentication and tries to implement it in Streamlit. And soon he has authentication, so that's good. But then there's Alice, a colleague of Bob. She has also developed an app, and she would like to have it deployed on the same server. When developing the app, she didn't really talk with Bob, so just by accident, she used a different version of Python and Streamlit, and it turns out these versions are not really compatible. So they asked the IT department to just install the other Python version and also the other Streamlit version, but the IT department says it's too difficult for them. It's possible, but they don't have the resources to configure it correctly. So yeah, the IT department refused to do this, and they are again stuck. So to conclude this story, Alice and Bob are stuck, and at the same time, they have the feeling that they spend most of their time managing the server, learning about security, certificates, all those things, while they want to spend most of their time doing data science and also work on the app itself and not on the server. So I think this is quite familiar for a lot of people trying to deploy things inside an enterprise or a company. So we can continue to the second part, which is more about ShinyProxy and how it can help solve such issues. So what is ShinyProxy? It's a tool that helps you deploy data science applications, and especially in an enterprise context, which just means it includes many features that are required in an enterprise environment. And ShinyProxy can be used to deploy almost any web application, but it's mostly used to deploy data science applications. And it doesn't really matter which framework you are using. So it's called ShinyProxy because we first used it to deploy Shiny apps, which are written in R, but you can use it also for Python apps that are written in Streamlit or in Dash or in Flask or Fast API. Any application is really supported. And at the same time, you can also host IDEs in ShinyProxy, like Jupyter Notebook or maybe RStudio. It also has fully integrated authentication and authorization, and this is using standard technologies so that you are sure you can integrate it with the authorization provider that you are using. For example, Azure Enter ID. ShinyProxy supports high availability, which just means you can run it on multiple servers, and if one server goes down, ShinyProxy will still work. It's scalable, so we will cover that later, but you can start with a very small server and go up to clusters with multiple servers. And the best thing is that it's 100% open source, so we don't have a separate enterprise version. Every feature is open source and can be used for free. So ShinyProxy has a UI, and when you log in, you will end up on a portal showing the different apps that are configured. You can give a name to every app. You can add a logo. You can divide the apps in sections. There are many possibilities to tune the UI, and you could even change the templates to have a completely different look. So I already mentioned scalability and use cases. So we develop ShinyProxy and it's free to use, but we also help customers with deploying ShinyProxy. And here I listed a few of these deployments. One of them, the first one, is just a simple Docker server. So just a server where we install Docker. There's maybe one app and a few users, but it can be much bigger. Like we have a public instance that is using Kubernetes for the clustering technology, and there are 200 apps and hundreds of users every day. We also have a cluster where we don't host data science apps, but instead we host IDEs like RStudio and Jupyter Notebooks, and this is used by 200 users. It's also running on-premise, so not in the cloud. It's fully on the servers of the company. Another use case is to embed like an app in a public website, so then users only see the application and don't really see ShinyProxy, but it's also possible, and this can scale to thousands of concurrent users. And another use case, the final use case I listed here, is more in a validated or so-called GXP environment. This just means it's typically in the context of pharmaceutical companies where they have very strict rules, and they need to comply with those rules. For example, reproducibility and audit logging is important. And just to let you know that ShinyProxy is fully, that it's, yes, that ShinyProxy has all the features to run in such an environment. And as you can notice, ShinyProxy grows with you. So you can start very small with a little amount of users and you can grow. And this is also, so this is in the number of users, but it's also in the complexity. So you can start with a very simple configuration. You don't need to learn all possibilities, just a few options. And then you can extend the configuration based on what you need and what you discover in the documentation, basically. So ShinyProxy makes use of containers, and more specifically Docker containers. So Docker is like a standard tool to create and deploy containers. And with a container, or like it's a software container, you can combine an app and everything it needs, such as the libraries, the dependencies, into an image, which is the container image. To create that container image, you write a Docker file, which is just a text file with instructions which tell Docker how to create that Docker image. So for example, if you create a Python app, you would specify which Python version you're using, but also which Python dependencies you're using, and so on. So why use Docker in ShinyProxy? When we developed ShinyProxy already a few years ago, using Docker was really one of the major features, and there are multiple reasons for this. One of them is that the app is bundled and installed into the Docker image. And every time that the user runs an app, a new container is spun up and serves the app. So this provides fully isolated workspaces for each session. And the major benefit here is that you can use different Python versions, different Streamlit versions, or completely different languages like R or Julia on a single server, and also that you don't need to install those tools on the server itself. You install them in the Docker image, but you don't need to install them on the server. So you also don't, like in the case of Bob, don't need to ask the IT department to install those tools. Another benefit is that Docker gives a lot of control on the memory and CPU usage of apps. By archiving the Docker images, you can archive every version of your app. And again, this helps to achieve reproducibility. Also important to know is you have Docker, which is more software you install a server, but there are also different ways to run the container. So with the same container, you can run it on a simple server or on a cluster using Docker Swarm or Kubernetes, but you can also run them in the cloud, for example, using AWS ECS. And all those backends are supported by ShinyProxy. We could add even more backends if there's a need for them. So if you look again at Bob's use case, of course, when you're working with servers, you still need a little bit of technical knowledge. You cannot fully avoid that, but we try to make it as easy as possible. and ShinyProxy is designed to handle most of the complexity here. So the workflow of getting started with ShinyProxy is basically that you first need to get a server. This can be an on-premise server, so a server in the office or in the data center. It can be a cloud server. It can also be a VPS, which is just a kind of cheaper cloud server, I would say, with less features, but it's good to get started. And if you want to scale to a lot of users or a lot of apps, you can also use Kubernetes clusters. So in the case of Bob, he just wants a simple server. So once you have the server, he can install Docker on it. And once you have Docker running, you can deploy the ShinyProxy operator, which is just a tool to manage ShinyProxy. So it's a bit like a helper, an additional component. And to install that, you just need a Docker Compose file, which is just a configuration file for Docker. The file is only 20 lines long. And when you do that and you start the operator, you are basically done. If needed, you can still configure authentication, which will be required in most cases. But from this point on, ShinyProxy is ready to be used. And it can immediately be used by data scientists. So there's no really any need for the IT department anymore. As you see in the 4 steps, there was no part where we installed the applications or where we installed Python or dependencies. This is not needed because they are installed in a Docker image and not on the server directly. So let's have a look at the use case again. So we deployed the ShinyProxy server. The next step is that for the app Bob created, he needs to create a Docker image. As I mentioned already a few times, it contains all the dependencies. Everything is in the Docker image, nothing on the server. Once you have the image, you can update the configuration of ShinyProxy or create a new configuration, and you are basically done. The app is running. So let's have a look at an example app. We have many demos on GitHub for all kinds of frameworks. You can also always request a new demo. We will be happy to edit. And of course, you start with your Python code. So just a file called app.py, which is just, in this case, a simple Streamlit app. And then you need to write the Docker file. And in this case, the Docker file is quite short. We just specify which Python version we want to use. And we install Streamlit, a few dependencies like pandas or numpy. And then we copy the application code, so the app.py file, into the image. And finally, the last line specifies how to run the application. So this is mostly the same as you would run it on your laptop, just using the Streamlit command in this case. And then we have to configure ShinyProxy. So we create a configuration file for it. In this case, we also specify a little bit of, we specify how authentication should be handled. In this case, we just specify the username and password. But of course, in most cases, you want to connect using LDAP or OpenID to your authentication provider. And once you configure the application, you just specify the configuration for your apps. It's just a list of applications you want. You provide an ID, like a display name and a description, which are just shown on the portal. And then also the name of the image and the port on which the application runs. So we can have a look at a short demo. This is just a small recording. So the user logs in using the username we configured. Then they see the landing page and they can choose the app. So in this case, we open the Streamlit app and then it already starts loading. In this case, it's one of the Streamlit demos that's online available. And you can start using the application as normally. And this is really, how it works. You log in, you click on the app, and you launch it. That's really it. So let's have a look again at some advantages of ShinyProxy. As you noticed, one of the main benefits of ShinyProxy is that it eliminates the need of overhead or boilerplate in your application itself. And this is done by providing the common features you need for every data science app in ShinyProxy. So for example, the portal to provide an overview of all your applications, this portal also allows you to run multiple apps on a single server without needing to configure paths or like reverse proxies and so on. ShinyProxy, as I mentioned a few times, authentication authorization is included, but also things like monitoring and logging, detailed usage statistics, and so on. So when using ShinyProxy, there are basically two modes to run containers. The first one is basically to run one container for each user. So whenever you start an application, a new container is launched for that user. This is what I talked before. The main advantage here is that the users are fully isolated. And this provides a high security because inside the container, there's only one user session being alive. And this can be, for example, a requirement for those GXP rules where you need very high security. Another benefit is that if you have an app that is computational, like that's heavy, like computational heavy, and it does a lot of computation, then you can really guarantee that enough memory and CPU resources are available to the app and to the user. And this can be done more easily by just having one container per user. Of course, there are alternatives like working with worker queues or with APIs. But if you just want it to be simple, you can just have a container per user. And the other option or the other mode to run your application is to share a single container with multiple users. So in the case of Python, this is the most chosen option, I would say. So you maybe can run hundreds of users on a single Streamlit application. And if you need more than that, ShinyProxy can scale the number of containers so that it spreads out the number of users among the containers, and that it guarantees that every user has enough resources and that every session is fast. There are two modes of running. These modes can be configured per application. They can be changed at any time. It's really just very easy to change it. There's nothing, don't need anything to configure this really besides configure it in the file. So no server changes, that's what I mean. There are many more advantages. ShinyProxy allows you to run multiple versions of the same app. So let's say you archived all those images, then you can configure ShinyProxy that you can that a user can choose to launch such an older version. And this is again important for reproducibility, where you want to be able to go to a previous version of your application, fill in some input data and see whether you have the same results. You can also launch apps on demand. This means just that when you configure the app, nothing is running on the server, but that when the user opens the app, the application is launched, and then only then application is running. And this is very useful if you have apps that aren't used often, especially those archived versions. You don't want to have them running all the time, just only when it's needed. As I mentioned, you can limit the resources used by apps and users. And this is really meant to prevent that users can disrupt each other, so that you don't have users consuming the full server. ShinyProxy is scalable, so you can start with a single server and go to very big clusters. On Kubernetes, it's also very easy to make ShinyProxy highly available. And when needed, you can have apps use GPUs. So if GPUs are available, you can just pass them to the app and the app can use them. There are many options to customize the behavior of apps. One option is to ask a user for some parameters. You can also read out the username and groups of a user, and based on that, maybe show some data sets or not show some data sets. So if a user is part of a certain group, then only then show certain data. With ShinyProxy, you can also open multiple instances of the same app. So for example, again, when you have a heavy computation, you might want to run multiple computations at the same time. And you can just do this by allowing the user to launch multiple sessions, and each session will have dedicated resources. So this really prevents you from needing to set up something like a scheduler or things like that. It's all handled by ShinyProxy. And running multiple instances can also be useful just to compare input data. Just live compare two versions of your input data, basically. And also ShinyProxy is fully compatible with CI/CD, which just means continuous integration and continuous deployment. This is basically just automation for deploying your apps, for building the images, for updating the configuration, and so on. But we really designed ShinyProxy to work with that. And again, it can be useful in those cases where you need reproducibility, because the configuration is all stored in, for example, in Git, where it can be retrieved, where all the versions can be retrieved. As I mentioned, you can run IDEs. One of those IDEs is, for example, Jupyter Lab, where you have, with IDEs, you have the same benefits as for regular apps. You can use different versions, you have different variants. If you run on Kubernetes or in the cloud, yeah, you have virtually unlimited amount of compute power available. If needed, also GPUs. And yeah, you can ask users to specify parameters like the amount of memory they need, when they want the IDE to be stopped. And just here a quick screenshot of Jupyter Lab running inside ShinyProxy. Other IDEs are supported, like things built on Visual Studio Code or Eclipse Theia, all those modern IDEs you can run. Just a quick mention of the ShinyProxy operator, which I, as I mentioned, is a tool to help you to get a production-grade and future-proof ShinyProxy server. And yeah, what you need to remember about the operator is that it will handle all the configuration changes. It can set up HTTPS automatically. It can set up the monitoring stack, and so on and so on. So here's just a quick demo of the Grafana integration, but maybe I will skip it so that I still have a few moments for the questions. So here's the final slide. I will just have a look at the questions. So one question is whether there is support for Podman containers, and yes, there is support. So it was made available in, I think, the last version or the version before that. So that's supported now. Then there's, I can show it, there's a version, a question about deploying Streamlit on Hugging Face. I have no experience with that, but I think it can be a very similar solution as ShinyProxy. Of course, ShinyProxy is used a lot inside companies on their private network with their own servers or with their own cloud. And I'm not sure if Hugging Face can do that. So with ShinyProxy, you need a server. And I think Hugging Face is more like a software as a server solution, but I'm not fully up to date on that. Yes, okay, so the question is basically, can it support any front-end library? And yes, the answer is yes. So ShinyProxy can really support any web app, basically. So if you use front-end libraries in Streamlit, it should really work out of the box. And I will just have a look at the chat for some questions. I don't think there are any. Okay, then I will just maybe go over the links I put here. So we have a website with lots of documentation. All documentation is also freely available. Nothing is hidden. You can post feature requests or bugs on GitHub. You can also start the repo on GitHub. And we do have support available if you wish. Of course, community support is also available. And I think that's it for this talk.
All right. Well, thank you so much for your talk today, and thank you to all of you for joining us. If you'd like to continue the discussion, please feel free to head over to Discord. The link will be available in the reception area. Also, a recording of this session will be available shortly for rewatching. And for those of you interested in more casual conversations, the lounge is open in the reception area for those smaller group discussions. But again, thank you so much, and feel free to continue enjoying our sessions. Hope you all have a great rest of your day.
Thank you.